So we've got sine of x plus 1. So if you remember the graph of sine of x, it usually goes through the origin. But if we do sine of x plus 1, that just means we've shifted it up. So here's just a rough sketch, actually. It should look like this. Because sine of x goes from -1 to +1. So if we add 1 to everything, then we go from 0 to 2. Okay, but you could get that from desmos.com or something like that. And then g of x, that looks like it's a linear function because x is in the numerator. It's to the first power. And then we got a y-intercept of 1. And the slope is 2 over pi. So that'd be something a little less than 1. So I think it's going to look like this. Again, you could graph these. That's fine. Just go to desmos.com/calculator and graph them. But we want the area of the region bounded by these functions. So we want this area. And so what we do is we find the area under the curve between the intersections for the biggest function, which I'm showing here in red. And then we're going to find the area under the curve for the smaller function, which is this blue one. And we're saying smaller with respect to the x-axis. This blue one is below on the x-axis. And when you subtract the red area by the blue area, you're left with this black area. Okay, so let's do that. Area under the curve. Actually, we need to know, this says 0 to pi over 2. That might be the intersection point. We really need to know where these two things cross. So to do that, you would set the two functions equal to each other. You'd plug this in over here. So if I do that, I've got 2x over pi plus 1 equals sine of x plus 1. You can subtract the 1's from both sides. And then we need to use arc sine to get x by itself, but then we have x also here. So this is 2 over pi x equals sine of x. And so if we suspect that this is the right endpoint, we could plug in pi over 2 to see if it makes a true statement here. Because in reality, what you're going to see is actually it's going to cross twice. You're going to get multiple intersections. We just want these two. If I was to plug in 0 in for x, which is what we're suspecting is the left endpoint, we get 0 on the left, and sine of 0 is 0. So 0 is indeed where these two curves cross. So it starts at 0, and if we think pi over 2 is the place where they cross again after the sine wave has come back up and then come down on the other side, then we should be able to plug in pi over 2 and get a true statement on both sides. So if you plug pi over 2 over here, you get 1 for a y value. If you plug pi over 2 in here, that's also 1. And the way I'm doing that without a calculator is sine is always the y coordinates on the unit circle. So when you plug something into a trig function, that's a measurement, that's an angle measurement. So this is rotating 90 degrees. So here is where that intersects the unit circle, and the unit circle has a radius of 1. So this is 0 on the x, 1 on the y. So the y values are the sine values on the unit circle. So that's how I quickly got 1. You could use a calculator too. It should give you the same thing as long as you're in radians. So this is the starting point, this is the ending point. That's nice because we'd have to do some tricky trig stuff to solve that equation too. Okay, so that means our integral for the big function is from 0 to pi over 2, and it's sine of x plus 1. And we can make this one big integral by subtracting this by the area of the smaller function. So subtracting it by, make sure to put it in parentheses, but subtracting it by 2x over pi plus 1. So it's the integral from 0 to pi over 2. I'm going to do some algebraic rewriting. I've got sine of x, nothing that's going to be able to combine with. I'm subtracting a 1 over here, so 1 minus 1 makes 0. So I made it a little bit simpler. So the antiderivative of sine is cosine. That's because the derivative of cosine would be sine. And heads up, I'm about to correct it, but in the video, first time through, I guess I had a lapse in judgment or something. I said the antiderivative of sine is cosine. It's not. The antiderivative of sine is negative cosine because the derivative of cosine is negative sine. So the derivative of negative cosine, negative makes a positive. And the antiderivative of 2x over pi, that's going to be x squared over pi because the pi is kind of funny, but that's just a plain old number. So you're only focused on the x when you're thinking about the antiderivative. This is just going to multiply after. So the power goes up by 1, but we have to make sure our antiderivative would turn back into our this function over here if we were to take its derivative. So that's why I got rid of the 2, because 2 comes down, multiplies, and the power gets reduced by 1. So this is the antiderivative of this term. We evaluate that from 0 to pi over 2. So we got to plug in pi over 2 here. And then this is, I'm going to factor out that pi as 1 over pi. And then this is pi over 2 squared. And then we need to subtract what happens when we plug in 0. The cosine of 0, that's an angle of 0, so that's right here. So that's 1 comma 0 in the unit circle. So cosine is the x coordinates in the unit circle. So if you plug in 0 degrees, cosine is 1. And then 0 squared over pi, that's 0. So cosine pi over 2 is 0 by the same logic up here. Cosine is the x coordinate. Pi over 2 is a 90-degree angle. And then over here, pi squared divided by pi makes pi. And I got 2 squared makes 4. And then subtracting 1. Let me see. So something's wrong because we're getting negative area. Should be positive area because we're above the x-axis. So I'm going to pause the video. There's something I've missed here. Pi squared over 4. Cancel out the pi. No, that sign's definitely negative. Okay, let me pause the video. I'll find out what went wrong here. Oh no, I'm a bad calculus teacher. The antiderivative of sine is negative cosine because the derivative of cosine is negative sine. So the derivative of negative cosine makes positive sine. So this should be negative. So that means this over here, there should be a negative 1. So this is the answer we'd want to plug into Newton. So just to set you up with the next one, remember your goal is you want to graph these. So you can go to desmos.com/calculator. Find out which one is the bigger function. So 3e to the x. You could do it through trial and error with some points too. So the red one is the e to the x, so that one's bigger. Then to find the area bounded by these two curves on the interval -1 to +1. Looks like they've just chosen -1, so you don't have to find out where they intersect. You can just integrate the top function subtracted by the bottom function. So -1 to +1, you want to be making this calculation. But I did the trig one because I figured everyone has a distaste for trig, and they'd rather me do that one. That's the setup. One last thing on this one, leave your answer in terms of e. So maybe this is your answer, something like this. Just make sure, no, there won't be a pi, but leave your answer in terms of e. E, remember, is 2.7 something something something. It's just a number like pi is.